that sounds very exciting.
What more could you ask for?
Not much. Looks like you've got 2 points there.
I do. I have 2 points, and this is the general equation of a power function. So, of course, you know f of x equals y. 2 points, x, y. So I'm just going to fill in this x value into my power equation there, and 30 is my y value. So I have 30 equals k. My x value is 81 to the p.
Fantastic.
And my second point, I have my y value is 20 equals k times 16 to the p.
So k and p are just standing for?
These are just constants. They're
Constants.
just some numbers.
Some number. I see. So you're setting up a system, 2 equations, 2 variables.
Right. This is a system of equations, and again, there's nothing special about doing this with power functions. As a matter of fact, you could find a linear equation using the same method. If you have 2 points, y equals mx plus b, you could put in the x and y's, and it's just a system of equations. 2 unknowns, 2 equations. I can solve for one of the unknowns and then plug in a point and get the other.
Very cool.
So I'm just going to try to get k by itself here. I'll divide both sides by 81 raised to the p.
Very nice.
So 30 over 81 to the p. That equals k.
Great.
If I solve this guy for k,
Yeah, why not?
I would have 20 over 16 to the p equals k. Now I didn't even really have to do that, of course. This is k right here. I could have just plugged it in for k right there. But it's pretty easy to get both of them for k.
Sure.
So this equals k, this equals k, hey.
Hey.
All right, so I guess I can set them equal to each other. Equals 20 over 16 to the p.
I'm liking this. Now you have one equation with one variable.
I do. Now I really hate to use this term. You know the term?
You're gonna say it, I know.
I'm gonna say cross multiply, but
I know.
really I'm gonna multiply these guys and these guys, but you really know what I'm doing. Really what's happening is I'm multiplying both sides by 81 to the p, and I can get rid of the 81, it can simplify by getting rid of the 81 to the p there. So that's 81 to the p, times 20, and then I'm multiplying both sides by 16 raised to the p. So that gets rid of the 16 to the p on this side, and you end up multiplying with 30 by it. But if you want to say cross multiply, what am I going to do?
I know.
I mean, that's really what's happening.
That's true.
Let's see. So I have 16 to the p times 30.
Beautiful. Hey, why don't you just rewrite that up in that beautiful open space? Because
I've got
otherwise
lots
you're
of
going to get
space
all
there.
smushed.
You're absolutely right. But you know, I'm going to do one thing at the same time.
Okay.
I want my variables on one side. So why don't I divide? Yeah. Why don't I divide both sides by 16 to the p?
I'm seeing where you're going. Very nice.
And you know what? I'm going to do something else at the same time.
You're just crazy, Mr.
Be
Haas.
too much?
No.
I'm going to divide both sides. What do you think?
By 20?
By 20.
Sure.
Divide that side by 20. Divide that side by 20.
You're just moving all your p's on one side and all your things without p
That's
on the
all I'm
other.
doing.
Just do an algebra. All right.
81 to the p. I mean, nothing special here. But, oops. Yeah, that's right.
That's right.
Right? 30 over 20.
Okay. No problem.
Again, nothing special about this. My variables on one side, and I got some number on the other side.
Yeah, we do this all the time.
Absolutely. So I'm just going to rewrite this a little bit. This bothers some students. If I have some number to some power and some other number to the same power, I can actually write this as 81 over 16 to that power.
Yes, you can.
Right? I
Think
mean,
about
that's
it,
really
that
what
makes
that
sense.
means. If this was 2, for example, I mean, I'm squaring the whole thing is the same thing as squaring the top and squaring the bottom.
Yeah,
That's all that's going on.
very nice.
This I can, of course, write as 30 over 20 is really just 3 over 2. Can I
Very
do
nice.
that?
Yeah.
Yeah. Now what?
Oh, hey, that's an exponential equation.
It is an exponential equation, and you know how to solve exponential equations. You need logarithms.
You need logarithms, unless you can do it in your head.
You know, some of them you might be able to. I don't think 16 goes into 81 evenly. I don't
No, but a
know.
2
But
can
a
become
2,
a 16.
Yes, you're right. Oh.
And a 3 can become an
Well,
81.
you're right.
I don't know if you want to go that route or not. But
You want to do that? Well, we could. I'm going to do this one with logs.
Okay.
And I think when it comes out, you'll be like, oh yeah, maybe you could have thought about what that is.
beautiful.
So I would say take the log of both sides.
Yeah.
I think that's going to serve you well in the long run. If I take the log of this side, you may have learned this a little bit differently. Still got me way over here, Ms.
I
Stewart?
still
And I'll
do.
take the log of this side.
It's looking good.
Yeah, thanks. You may remember this log rule. Log of something raised to an exponent is the same thing as that exponent times that log. Remember that rule, Ms. Stewart?
I do.
Running out of space a little bit.
You're doing fine.
Thanks. I want to get p by itself, so p is equal to, I'm going to divide both sides by this whole guy. Log of 3 over 2 divided by log of 81 over 16. This is just going to be a calculator maneuver.
Stick it
at
in your
this point.
calculator.
Just
All
stick
right.
that whole thing, make sure your parentheses are there.
I'm going to use my brain as a calculator. How about you, Mr. Haas?
I think I pretty much got what it is.
What do you think? You write it and I'll say, oh yes, that's it.
Yeah. Now, I mean, how did you know it was to the 1/4 power? Well, of course, because if you take 3 and you raise it to the 4th power, 3 times 3 times 3 times 3 is 81, and 2 times 2 times 2 times 2, is that enough 2s? 2 times 2 times 2 times,
Yeah.
is 16. So of course, the 4th root of this is this. So Stuart knew immediately that p was 1/4. But of course, you can use logs for that. So I'm almost done. You get me
Alright.
over here?
Yeah.
So again, my original equation,
Woo, panning over.
y equals k x to the p. What do I have so far? Well, I have p is 1/4, and I have an xy point.
Oh,
Maybe I'll use this guy.
sure, you can pick any
Either one.
point. Good.
20 equals k, my x is 16 to the 4th. Well, I already know what 16 to the 1/4 power is. It's 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16.
Beautiful.
So this is 2. 20 equals k times 2. Divide both sides by 2.
Wow.
Yeah.
This
so
is a big problem.
k equals 10, and I can write my entire solution right here, I think. Y equals 10. X to the 1/4 power.
Wow,
Little
Mr.
messy
Haas.
there,
That is a humongous problem. But basically, you're just doing the algebra that you've done throughout, you know,
Nothing
the
new.
last couple of years. Nothing new. It's just putting together a lot of algebra.
Thanks, Mr. Stewart.
Thank you. This was fun.